let you take the show away.
Awesome. Thank you. First of all, happy Friday. Um, and I'm super excited to be here. Very grateful for this opportunity to thoughtbot, their whole amazing team, um, to very thankful to the whole team at thoughtbot for letting us join on this open summit. Um, um, I'm not sure if some of you may have seen. There's this project called Langchain.rb that we've been working on, and today we're gonna focus on it. I'm gonna do a probably 30 to 40-minute presentation, talk about the current Gen AI landscape. We're gonna hit some buzzwords like RAG, AI agents. I'm gonna kind of explain what those are. We're going to play around with the library. We also have our colleague Daniel Mello on the stream, and him and I were going to pair up on some issues. We're going to open the floor for Q&A as well, and answer any Gen AI related issues. So let's start out with the presentation. Okay. All right, so hacking on Langchain.rb, you've joined the thoughtbot Open Summit 2024. Let's dive in. So first of all, again, huge thank you to the thoughtbot. We are not part of the thoughtbot team. We are friends of thoughtbot. So thank you for letting us join in and kind of showcase Langchain.rb. So in my day-to-day, I run a small software development agency called Source Labs, where we build custom applications for VC-backed startups and medium-sized enterprises. And we do a lot of open source work, kind of focusing on applied AI work under the banner of Patterns AI. So I think this slide kind of summarizes the Gen AI impact pretty well. So previously, if you wanted to develop, if you wanted to add AI capabilities to your applications, it would have taken about 6 to 7 months. So you had to spend about a month labeling data, then training a custom model, and 3 months kind of deploying, optimizing it. And now with the rise of Gen AI, you could do a lot of things that have previously taken a very long time in a matter of few days or weeks. So some of these very common machine learning tasks have gotten much easier to implement. Things like converting unstructured data to a structured format, summarizing large documents, classification tasks such as taking text documents and bucketing them by topics, even OCR. So there's a lot of people kind of making claims that you don't need to use tools like Tesseract now. Actually, doing the GPT-4 vision offers much better OCR capabilities, language translation, content generation, named entity recognition, etc. All of these capabilities are now an API call away. And as the cost in developing these capabilities have significantly dropped, the adoption increases kind of towards the right on this chart. So these capabilities are no longer reserved to large enterprises, kind of tech-first FANG companies. Now there's a long tail of medium-sized companies, smaller companies that can easily add these capabilities to their applications. And in fact, I want to present the vision that I believe we're very close to having AI integrated into every single tech stack. So just like every single tech stack nowadays has a database, has cache, encryption queues, Lambda function storage, protocols, you will have this intelligent compute engine in your application responsible for a variety of different tasks where intelligence needs to be injected. And in fact, I actually think we're going to have AI agents in every single enterprise, kind of chipping away responsibilities and tasks, subsets of job functions of different departments. Of course, when we talk about Gen AI and specifically large language models, text-based models, they are not without their faults, and there are everyone brings up hallucinations, so models generating incorrect text or nonsensical text, and they're trained in a snapshot in time. So for example, the GPT-4 before the GPT-4o update, that model was trained on data up to April 2023, and depending on how it's integrated into our application, our proprietary knowledge is not leveraged, not utilized. So in order to combat that, you may have heard the term that has been just thrown around constantly, which is RAG, retrieval augmented generation. And it's actually a quite a simple idea. So LLMs respond to, and we interface with LLMs by sending them prompts. And what RAG does is that we enhance prompts or augment prompts with our knowledge base, our proprietary data, and really the relevant context. So we would take a query, maybe it's a question from a user, augment it with relevant context, package it all up in a prompt, and send it to the LLM and get a response back. And a common way of implementing RAG is by using vector search databases. And vector search databases operate on vector embeddings. And vector embeddings is a technique of encoding semantic meaning into a vector or an array, in other words, an array of float numbers. So for example, on the right-hand side of the slides, you can see that we take a string. The Ruby programming language is 30 years old and has stood the test of time. Isn't that true? We put it through an embedding model, and it spits out an array of float numbers. So, for example, one of the OpenAI's model uses a vector of length 1536. And in order to try to visualize it, of course, the human mind can only really visualize 2D or 3D spaces, and so there's no way to try to visualize a vector of a dimension 1536. But if we were to try to represent this in a 3D space, you could see the blue dot there kind of represents its location in this vector or latent space based on its semantic meaning. So when we execute semantic search or vector search, or another way to refer to it is similarity search, we're calculating the distance in this multi-dimensional vector space. So we're searching, given a query, we're searching for what are the closest semantically meaningful vectors in that vector space. And there's kind of a variety of different distances, types of distances to compute. But we're searching for nearest neighbors. This is another really cool kind of chart. You could see that this research organized news titles based on different ideas. So you could see that things that have to do with sports, the news titles are all clustered together. Politics and conflicts are in a different cluster, and etc. So um, there's some complexity to how RAG can be executed. And one component of it is putting a prompt together. A very simple, naive example is that you take the context, right? And you take the original question, and then you specify that the answer follows. So you fill in those concatenated values, you pass it to an LLM, and the LLM returns the answer. And again, here's kind of another way of looking at it. So if a user has a question, how do I X? We refer to the knowledge base. We execute the similarity search, vector search. We pull the relevant knowledge, or basically those search hits. We add it into the prompt and then send it to the LLM, and the LLM generates the answer. So no AI wave happens without talking about AI agents. And AI agents is actually not a very new idea. So in Alan Turing's famous 1950s paper, where he introduced the famous Turing test, he actually talked about the intelligent machines, and we explored the concept of expert systems in the 1970s and 80s, software engines of 1990s, 2000s, the original chatbots of 2010s with Alexa and Siri, and now given new capabilities, we're building LLMs as agents, or LLM-powered AI agents. So in fact, every massive tech company has a vision around this. Google has this AI agent builder called Gem Manager, ironically called Gem Manager. And Salesforce is staking its own fate of a company on their what they're calling Agent Force. So what is an AI agent? And the textbook definition is that an AI agent is an autonomous software system capable of perceiving its environment, making decisions, and taking actions to achieve specific goals. So environment awareness, decision making, and action taking. And these two terms are kind of used interchangeably. AI assistants, AI agents, I certainly use them interchangeably as well. I draw this minor distinction that assistants are more conversational, so they're continuously taking directions or feedback from human, and agents are more autonomous, kind of like background jobs or background tasks. You basically give an assignment to the AI agent, and it goes on to execute it. So what are some of the main use cases? So of course, it's broadly automating business processes, like automating low IQ, mundane tasks, or serving as a personal assistant, kind of co-pilot style interaction interface, and automating time-consuming tasks. So in instances where a human cannot moderate a million images within an hour, an AI might be able to, or is able to. And when you think about building an AI agent, there's kind of a lot of different components that go into it. So there's reasoning and planning, which is its ability to take a set of tasks, take the goals and objectives, or a workflow, breaking down into a series of smaller steps and plan out its execution. There are triggers, which is basically a concept of how do these AI agents run. There's memory, because the LLMs behind these AI agents are stateless. So we need to be able to maintain its progress, maintain and save and update its progress throughout its execution. There's tool and function calling, which I'll explain in in a couple slides and evaluations. We need to be able to evaluate or rather test these AI agents. So whenever people talk about reasoning and planning, they talk about the chain of thought, and really all it is it's forcing the AI to explain its reasoning. So kind of similar to how humans, whenever we're posed with a problem or a question, if we think carefully about it, if we think out loud, we're much more likely to arrive at a better answer. And this is the same concept. You're basically forcing the AI to kind of explain its reasoning. So as it's generating tokens, it's much more likely to um, be much more kind of calculated and deliberate about its answer. So if we ask it this random brain teaser, like how many soccer fields would be needed to cover the distance between New York City and DC in a straight line, and it tries to just answer right off the bat, it's much less likely to produce a correct answer than breaking the question down and figuring out what are the different steps needed to try and get to the correct answer. So that's chain of thought. So again, triggers, a very simple idea, should be very intuitive to any software engineers in the audience. So how do we trigger a system? How do we trigger these AI agents to run? So either it observes some sort of a strawberry, right? Either it observes some sort of a state change, where just like humans, we're standing at the stoplight looking at the lights change, or the AI agents can be run on a schedule. So think cron tabs, event-driven, web hooks, or manually run. Again, memory, very simple concept, saving the context, execution progress, or tool calling to memory. So let's talk about tool or function calling. And basically, there's kind of two purposes behind it, which is either and or generating structured outputs. So generating a response that adheres to a predefined JSON schema. So if we want to be able to program against these things, we need some sort of a contract, and JSON serves as a really good contract to interface with these systems. Or the intent detection, the LLMs can use external tools. So think APIs, third-party dependencies, etc. So you would want to use tool calling to kind of do the following: to either get data from external sources, APIs, get real-time data. As I've mentioned earlier, the LLMs are trained on data that's a snapshot in time, so it has no concept of state or time and space, and it's unable to kind of get real-time data. So you need to call into external services. The intent detection, you can get it to execute and take actions. And then also, because the LLMs are probabilistic systems, it doesn't really make sense to have it execute deterministic tasks, for example, doing math. And there's, and I'll drop the link in the chat. There's a really good link here to a blog post called "Math is Hard" by Gary Marcus, kind of elaborating on this point. So, for example, without tools, if we try to get it to sum two very large numbers, it actually hallucinates the answer. So this looks like a correct answer, but it's not. But it also doesn't really make sense to use LLMs for this task. And the solution is just to have it generate code or a math expression that could be evaluated by a calculator or by a script in a programming runtime environment. So tool calling is a way to show or tell the LLMs are available tools or functions. Again, those are kind of used interchangeably. I like to think of tools being a collection of functions. So one tool consists of lots of different functions. So on the left-hand side, you can see that we have a inventory management, find product function, and a description of what that function does and the parameters, rather a single parameter that it takes, which is just the product SKU. And then on the right hand side, if there's a user message that we send to the LLM that kind of has a similar context, then the AI might choose to invoke this function, and we can take this function call function invocation and execute that tool manually in our application and send the result back. So Langchain.rb is a Ruby framework for building LLM-powered applications, and the kind of example illustrated here is what we're calling the unified interface on top of all the different LLMs. So you might be aware there's kind of a race to building or training the best LLM model, and all of these massive companies are constantly competing for which LLM is more capable in which instances, foundational models, and it's an actively evolving field, actively researched. We don't know which LLMs are going to be great or the best to use, and we're kind of just saying, here's a unified interface. If in 2 weeks you want to swap out from Anthropic to Google Gemini, you can. If if 3 months later you want to swap out and use OpenAI instead, you can. You don't have to change the the contract. It's the same interface. So let's explore some of the Langchain.rb features. So I think you could see my terminal. If not, please say so. So the first thing you would do in your Ruby application is just simply gem install Langchain.rb. 0.19 is the latest version. I'm inside of our repos directory, so I can just load our environment that has all the dependencies and has all of the environment variables loaded. I basically have a .env file, and there's a .env.example file with kind of all of the different environment variables you might need if you use those systems. And mine basically has all of the relevant API keys and environment variables. So like I mentioned, we can, of course, start with some very simple examples and kind of use OpenAI. So we just need to pass it the API key, and then we can send it an array of messages and get a response back. Hello, how can I assist you today? And you can see that this message came from role assistant. And oh, sorry, let me. Oh, my bad. Okay, so now we can just kind of take its output and continue the conversation. I think it said, hey, how are you doing today, or something like that. And we could say, I need some help. My computer won't turn on. And it replies with, I'm sorry to hear that. There are some steps you can try to troubleshoot the issue, ensure that the power cable is securely connected, of course. So we basically just have a chat interface with the with LLM. So if instead you want to use a different LLM provider like Mistral AI, we would just change the name of this constant here, change the name of the API key, and basically we can continue the same interaction. And Mistral says, I'm sorry to hear that you're having trouble with your computer. Let's try to diagnose the issue. So kind of against the very similar in spirit and intent. Now you might be wondering, like, can we use a local model? And of course we can. We have an adapter for Olama. And I'm going to, so you can use a very similar chat interface with the same kind of method signature, but I'm going to use this opportunity to also show you the completion endpoint, which is the .complete endpoint. And this, instead of accepting an array of messages, this accepts text prompts. So an example of a prompt could be once upon a time, and we will basically let it finish that sentence. And you can see that we're using Llama 3.1 by default, but you can use any other open source model as well. In this right here, you can see that we're making a post request to our local host, 11434 port. And it continues with once upon a time in a far off kingdom hidden behind a veil of sparkling mist and towering mountains, ... We can also, I talked about RAG and vector embeddings and doing vector search, semantic search, similarity search. And in order to generate those embeddings, there are dedicated embedding models, as I mentioned earlier, and we can take an LLM and call .embed and give it any kind of text. So let's say I'm super happy to be co-hosting the thoughtbot Open Summit 2024, and it will generate the embedding. So just to kind of, so I'm just gonna illustrate this. So I'm gonna save this to a response, and if I'm gonna look at the generated embedding, it's, like I mentioned, is very long. It's of length 4096. So next thing I wanted to illustrate are the prompt templates. So the prompt templates is basically a way to create, save, manage, maintain, version different prompts that are frequently reused. So I believe I created one earlier. Yeah. So we can save it to JSON. So we support JSON and YAML formats, and we could take a look at this one that I created earlier. So basically, it's a YAML format, and the template is please summarize the following document, and then we concatenate the text inside, and we give it a hint that the summary must follow. And we specified the input variables here of a text, which corresponds to this variable here. And so now when we go back into our console, and we can use our Langchain prompt class and load our load our prompt template from the local file. So let's go with prompt template file path. Okay. And we can, again, inspect the input variables. So in this case, this prompt template does take text. And I'm going to try to find random text from somewhere. I should have had something handy. Okay, so I just pulled a random article from Wikipedia. So if we insert this, of course, I think we could do, is it EOS? Okay, so we've got this text variable about someone, some musician, I believe, and we've got our prompt template, so we can now format it and pass our variable, and this will output the prompt, right? So please summarize the following document, and then we insert that text, and then the expected summary follows, right? So let's use an LLM. So let's invoke the Llama again. This runs completely local, so never sends any info anywhere to the cloud, never leaves your computer. And we can use the complete endpoint and then send our formatted prompt template with our text and produce the response. So the document appears to be a brief biography of an artist named Cartier. Here's a summary, ... Okay, so next thing I wanted to show you was a simple RAG example. So if you look at our documentation here, you could see the variety of different vector search databases that we support. You know, if you're using Elasticsearch already, maybe it's a good idea to use the Elasticsearch vector search capabilities within your database. If you're using Postgres, you could just add Andrew Kane's PG vector extension. Milvus is a really good one with a lot of enterprise-ready features, and that's the one we'll just use because that one's been at the top of mind lately. So, of course, we still need an instance of an LLM because we're going to use the LLM's embedding models to generate embeddings to generate these vectors that are stored in vector search databases. So we need this LLM variable, and I'm just going to paste some code from here. And again, very just like the unified layer on top of different LLMs, we try to maintain a unified layer on top of different vector search databases. So if you would like to use a different one from the list that I showed, you just replace this. You replace this constant. But in this case, we're going to use the Langchain vector search capabilities. We're going to use Milvus. I have it running locally, actually in here, in a Docker container. I created an index called testing and we're gonna pass our LLM instance because that's what's going to be used to actually generate embeddings. And the use case that I wanted to show was actually uploading a copy of my rental agreement for the apartment, my lease agreement. It's a very long PDF with a lot of kind of boilerplate legal language. And we can use these capabilities to try to ingest a lengthy PDF and basically ask questions about it. So because I already did that, I already parsed the PDF and generated the embeddings and stored it in a Milvus database. I didn't want to spend like a couple minutes doing that and just watching the process sit there. It's in the docs, you can see it. But we could just jump into answering questions. So we have this very simple interface called just .ask, and we could say, what is the duration of our lease? Live demos don't always go as smoothly. Okay, let me try a different question. We have pets in our apartment. Okay, yeah, so I must have botched something in the process. But the other thing that I wanted to show you is actually the Langchain the assistant class. And I showed you the LLM .chat interface, and the Langchain assistant tries to abstract the differences between that chat interaction interface even further. So we can create a simple, so let's use an LLM again. We'll just use OpenAI. But again, any LLM provider that has a chat interface will do. OpenAI API key. And then we can instantiate our assistant. We pass the instance of an LLM. And that should be it. And now we can, so it stores the messages that are kind of exchanged between the assistant and you, the developer, or you, the user. So we can send it a message and say, oh, how are you? And now we have that message in the list. And in order to run the assistant, we just call .run. And so after these kind of explicit logs, we see that at the bottom we get the collection of messages that's currently in there. So again, we're gonna continue the conversation, and we're gonna tell it that my computer is not working. It will not turn on. So we have three messages in there total, and we can run it again. And it tries to help us by giving us some troubleshooting steps. Okay, so this is great. So this is a very simple example. And the other thing I want to do is I actually want to use some tools. We have some pre-built tools One of them, for example, is the news retriever. I have to look up what the name of that environment variable is. My apologies. Okay, so this interfaces with an external API. I think it's news.org or something along those lines. So we've exposed the news retriever to our AI assistant. And now I could say, we actually have a shorthand called add message and run. And we can say, I feel like this is not a good question because there's always news about AI. So we're going to send it a question, say, whatever latest news about AI. I mentioned earlier, LLMs are stateless. They have no concept of space, time, and state. And please ignore the logs flooding, and I'll explain what it's doing behind the scenes. So if we look at the paper trail of messages, so we could see the user message that was sent, which was asking what are the latest news about AI. The assistant responds with a tool call or a function call. So it's invoking this internal Langchain tool news retriever, and it invokes the get everything function and passes the query as just the AI string, sorts it by publish that because we asked it for the latest news, and it just asks for page size of 5. So we execute the tool, which actually goes and talks to the API and responds with a bunch of summarized news articles. It's not super straightforward to read, but this is what gets returned. We send it back to the LLM, and then or rather send it back to the AI assistant, and it responds with kind of summary. So here are the latest news articles about AI. Can AI be artist? A Sotheby's auction tests the answer while human artists protest AI training. The auction house will test the market for AI-made art at a moment when human artists feel AI is unfairly exploiting their work. So this was an AI assistant that was using the internal news retriever tool. We also have a database tool, which I think is actually a really good use case, which is text to SQL. And this database tool takes a connection string, and I have a database running locally. It's a Postgres database, just called MyDB. So this is a real Postgres database from a real client project. I'm not going to tell you much about it. Basically, it's an app in the e-learning vertical e-learning space. And so we can say, so we can add message and run, and we could say, how many users are there? Right, and we're asking it specifically about the database. And what it does is it sends a tool call to our internal tool called Langchain tool database. The execute method, and it sends the following SQL query: select count star from users. We execute the tool, we get the count back, and it just kind of remixes this and tells us that there's 3,000 plus users. We can get a little bit more, we can ask it something a little bit more complicated, like how many users have earned at least one certificate. And so this is interesting. So I followed up our conversation that we were having with how many users have earned at least one certificate. The assistant invokes the database tool again, and we send the following query: select count distinct user ID from certificates where earned equals true. We try to execute the SQL query, and we basically just pasted back the SQL error and say, well, the column earned doesn't actually exist. And it tries to, and it generates a different SQL query. So select count distinct user ID from certificates table. And this is in fact the real table along with the users table. And we get this count back, and it replies with, yeah, there are 1,895 users. So because our firm worked on this project, I'm going to ask how many users are from Source Labs LLC, because we have test accounts and things like that. And so it tries to execute this query, which is select count from users where company equals Source Labs LLC. We tell it that company is actually not a valid field. It tries to self-correct, and it invokes a describe tables function and passes the user's table, because it's trying to understand more about what does the table actually look like. And we output basically the create table statement, SQL statement, right? So when you're executing Rails DB migrate, if you look at your I believe structure.sql, you will see these create table statements, and so we're basically telling it what does the database look like. And so using that information, it tries to autocorrect and generate a valid query. And there's 3 users from our firm, so 3 developers that worked on this project. So that was text SQL. Let's go back to the slides. So the Ruby on Rails promise has always been developers focus on writing business logic and not the plumbing, right? Which is why we all think that Rails is one of the most productive web development frameworks ever. And in the old world, we believe before AI, business logic has always lived in models or service objects or controllers if you're bad. But in the new world, a lot of the business logic is gonna live in prompts. So I want to set up another demo. I want to kind of set the stage for another demo I'm going to do. So I want to introduce this fictional e-commerce store called Nerds and Threads that sells comfortable nerdy t-shirts for software engineers that work from home. So please raise your hand if you would buy a t-shirt from the store. I definitely would. And an e-commerce store integrates with lots of different services. So customer management, email service, payment gateway service, shipping service, inventory management, order management. And what we're going to try to do is we're going to try to put the AI agent on top of all of these services and have it orchestrate the business logic that will run this store. So if we take, for example, a customer management service, and I'll drop an example to this demo in the chat as well, that I'm going to do in a second. So if you look at the customer management service, we basically extended with Langchain tool definition class And this enables this beautiful DSL where you can define function and kind of declare your functions, which are actual methods in the class. So there's a very simple like create customer method and find customer that takes an email, etc. And what we're going to try to do is we're going to try to package up some of the logic that you might see in behind an e-commerce store and try to give it to an AI agent and have it executed. So we have some instructions here for what needs to be done when a new order is submitted. So when a new order comes in, we need to create a customer account if it doesn't exist. We need to check the inventory for items. We need to calculate the total amount. We need to charge the customer, create order, create shipping label. If the address is in Europe, use DHL. If the address is in the US, use FedEx. And then we need to send email notification to the customer. And we need to execute this sequentially, non-parallel in that specific order. We have some instructions on kind of returning the order as well. And this is some of the code that we're going to run behind the scenes. So these are our instructions, or I'm also referring to them as standard operating procedures. And you've seen this class before in the terminal. We're going to use our AI assistant. So let's jump to the demo. Okay, and I hope you can all still see this. And again, just to avoid having you observe me typing for a very long time, I'm gonna paste the instructions here. So again, as I mentioned in the slides a second ago, we're giving it some context about what its purpose is, what it's doing, what it has access to, what its responsibilities are, and we're giving it our standard operating procedures for creating a new order. And so if we have a point of sale system that produces a header, like a new order header, and then a recognizable format that a customer email had purchased a quantity of 5 of this SKU, and this is their address. This is not my real address, so just FYI. And when we try to run it, we can see the execution flow. So the AI agent is actually stringing all of those different services and submitting and processing the new order, right? So we don't actually have the code for this. This is being done on the fly. So we find the customer and the record is found in there because I've kind of run this before as I was testing this out. So there's no need to create a customer account. We find the product, we charge the customer, we create the order, we create the shipping label, and because the address is in the US, we use FedEx, and then we send the email notification. So now, let's say our point of sale system produces this new header with a new event, return order, and this customer changed their mind and wanted to turn around and return this wrong size. And our AI assistant says that it can only process new orders. It doesn't know how to return orders. So what we can do on the fly is actually change our business logic. So we can append these instructions at the bottom, and we could say, well, now you could do, now you know how to do, how to return orders, and these are the step-by-step instructions. So look up the order, refund the payment, mark the order as refunded. So let's try to resend this. And it goes through with the return. So why would you use this? So you're definitely empowered now to tackle really complex workflows. You can inject intelligence in your process, and you can also change the requirements on the fly. So um, imagine you're running an e-commerce store, and the CEO comes in on Monday to your product team and says, I forgot this is the 10th anniversary of our e-commerce store, and we need to offer a discount to our loyal customers, and here's the criteria for what a loyal customer is. And the product team's like, well, we're doing scaled agile, and we haven't had our whatever it's called, Scrum increment, and not in this quarter, not in this sprint. So and but maybe you could kind of enhance some of this business logic behind the scenes in a prompt, kind of quickly test this out, because I think a lot of Rails development is kind of stringing systems together. So I really like this abstraction. And why Ruby? Like, why are we doing all of this in Ruby? Because Python has kind of won the hearts of academia, and a lot of this AI, ML, DS work is in Python. And we're really targeting the the Pareto principles, like 80% of the use cases, or another way to put it is we want the Ruby teams to put in kind of 20% of the effort to get 80% of the returns or 80% of benefits back, so that you don't have to think about, oh, we're gonna spin up a Python team. We don't have any Rubyists that are versed on Python or in any of this, so we need to stand up a separate Python process and all of that. We just, we want you to kind of continue on with your majestic monolith and move fast and build these capabilities really quickly. And also, Ruby is a beautiful language. It's just this. It's a high-level language like Python. I think we also ought to have these capabilities in our tool belt. So we talked about the Gen AI wave. We talked about what RAG is, how to do it. We talked about vector search databases, vector embeddings. I introduced the Langchain.rb to you. I showed you some of its core features. We looked at AI agents. We also automated an e-commerce store and injected an AI agent to facilitate and execute the business logic. So we've been kind of running this open source project for about a year, maybe a little bit more, a little bit longer, and this is my first open source project that really has gained some traction. And some of the things I've learned through this experience is that you have to be responsive, because we have such a low attention span, and that when people check out your tools, they kind of expect to get answers very quickly, or get bugs fixed, or get new features introduced. So while not always, we try to be responsive. The Ruby community is very friendly, obviously, and I think this extends largely to open source in general. And you have to be helpful in order to for an open source project to be well regarded. And so, of course, none of us would happen without some of these individuals. I think we've had over 100 people contribute to a project in some capacity, whether it's a larger feature or fixing the typo in the README, and all of this has been greatly appreciated. And that's it. So actually, I didn't get a chance to update this QR code, but this was supposed to be a link to our Langchain.rb Discord. I'll drop an invite in the chat as well. Please feel free to email me or reach out to me or Daniel about anything that you've heard in this presentation, or if you have any ideas or constructive criticism, very open to all of it. And I think we're going to open up the floor for questions now. Thank you. Okay, so let me drop a link to the Discord. Okay. Are there any questions? I'm just scrolling back in the chat. Also, if you'd like to come up and have more of a face-to-face, I'm happy to bring you up. So I see Zach's comment about zooming in. My apologies, I didn't see it earlier. Hey.
Hello. Wow, people are ruminating on all of the good work that they just saw. I thought I could ask some questions to get us rolling.
Let's do it.
Why? I mean, the one that is on my mind after what you mentioned about this being one of the open source projects that has gained traction. I wonder if you can talk more about reasons why you think that might be, why this has gotten a foothold. I think that it's probably more than just the hype of AI world. I think, but I'm interested in your thoughts and what stands out about this project for you.
Yeah, I mean, I'll kind of mention the history. So end of 2022, we've just finished a large client project where we basically built a full text search on top of Elasticsearch, and it was a data pipeline that was indexing 50 million public policy documents into Elasticsearch, and we built a web UI where you can kind of search and do full text search and subscribe to like different updates. Like you could do, like, if anyone knows what Elasticsearch percolation is, where you basically save a query and then you get notified whenever there's new matches, new documents that are pushed to that are matched against that query. And so we finished this project at the end of 2022. And the end of 2022, the beginning of 2023, this whole ChatGPT craze was happening, and I just thought to myself, wow, we've spent all this time developing this full text search, and it's amazing, but it just quickly became kind of inadequate because now all of these new capabilities were on the market. And so while the client was super happy, this is amazing, but I just thought to myself, like, wow, like, but now you need to build chatbots on top of it. Like, you've just delivered, and this was a SaaS product, and they had these massive like Fortune 500 customers, but they're gonna start asking you like, can they chat with it now, right? Because this is what they're seeing. They're seeing ChatGPT, and this is how I ended up diving into vector search and semantic search. So being able not to just search by keywords, but also being able to search by meaning. And this led me to discovering some of the tools that were built in Python. And really, this was my attempt to, instead of messing with Python, I just wanted to have my own tools. Like I want to work in the Ruby environment, because that's the best language for me. It's I think it has the best syntax, etc. Like I want to use two spaces. I don't want to use I don't want to use tabs.
Relatable.
I don't understand why that matters. And so the first piece was the vector search kind of component, and building RAG, and then going into some of the auxiliary things, some of the related things, and I think now we're really trying to hyper focus on agents, and how agents can sit inside of your applications, how they can have deep hooks via like tool calling, function calling into your application. And then how can you express your processes, your business logic? Like, what does that look like? Mm-hmm. And we're toying with some ideas, like expressing it as like graph database nodes, kind of a decision tree, versus like the step-by-step like textual that I showed. And how can you automate these processes inside of your applications? So that's kind of and we're trying to like shape the project around that, right? So the prompt templating is also relevant, and the RAG is also relevant, and like all of these connections to different systems is also relevant. So that's kind of the overall shape we're trying to take. I don't know if I answered your question, but I think to be like completely intellectually honest, like I think the name Langchain.rb also played a role, right? Because people heard about Langchain, and they would probably search Langchain Ruby, right? And this project would pop up. And but it's been a two-sided sword, because while the Python Langchain is extremely popular, I think there's also a lot of anecdotal kind of accounts, evidence on the internet, where people just complain about it, because it has a lot of like unnecessary abstractions, and there's like so much functionality. Like, why does it need to be that broad? And because it's basically tech debt. Like, you have to maintain all of it. And I say that while Langchain was an inspiration to some of the initial ideas, we soon realized that we have to lean into the Ruby way of doing things, right? And we have like our amazing tools and our ways of doing things, and we need to bring a lot of those concepts to Langchain, right? Mm-hmm. And I think in the Ruby world, we're a lot more pragmatic. We kind of hate reinventing the wheel again. Like I mentioned, the Rails promise was focus on the business logic, like on delivering business value, and not doing the plumbing, right? Like not trying to figure out the compatibility between like all these different like JavaScript libraries, or like how do you build a front end, or like you look at package managers in different ecosystems, like Bundler still just blows everything else out of the water. Mm-hmm. So those are kind of like some truths that we hold as we think about like where this library is heading. Yeah.
Yeah, I think it's evidence that that there's an appetite for this kind of tool in the Ruby ecosystem, that developers are looking for a way to do this that is more like standardized and straightforward and plug and play.
Yep.
So I see we have 2 questions in the chat, and I will put them up on the screen. I'm actually going to adjust the screen just a little bit. There we go.
That was great.
So we've got, I don't know how easy and quick, but can you explain how the retries of the queries work in the back end? The SQL adjusting that you had shown before, how it received obviously that it was the wrong query, that it wasn't going to work, but how does it then decide, okay, well, let's try something else?
Yeah. So we have so I'll first like describe that internal database tool, and it's actually rather simple. And I'll drop a link to that class if you want to dive in. But basically it uses the SQL SEQUEL gem library behind the scenes to connect to any kind of SQL database, SQLite, Postgres, right, MySQL, and it has a couple of functions like describing tables, right? So you call the describe table and you expect that you get the definition back. Like, what is that table? What does the layout of a table actually look like? Mm-hmm. It has a way to, it has a execute function, which you just pass it a SQL query and you execute it. And that's really it. Oh, and list tables. So get a list of all the different tables, right? And I will say it helps having a well-structured, normalized database, mm-hmm. right? Because if you're like, you have to be able to infer what the database is for, or what some of those columns are, right? Like, mm-hmm. one of the most challenging things in programming, right? Like naming your database columns so that they make sense. So first name is first underscore name. It's not FN, mm-hmm. underscore whatever 01. Like, even to a human that means nothing. And so our AI assistant, and also the database tool has a description for all those different functions, and for the tool itself, like, what is its purpose, like how to use that tool, how to when to call those functions, etc. And so when we use the AI assistant with that database tool, and we ask it a question, it generally tries to be helpful, and we can kind of steer its behavior or style of response in the instructions. But when we ask it, like, how many users are there, and it generates a wrong SQL query, so we try to execute that SQL query, and then we just get a raw SQL error back, and we pass it back the error. And there's a role. So I showed role user, role assistant. There's also mm-hmm. a role tool, which means that it's the output of the actual tool execution. And so when it sees that SQL error, like, it tries to autocorrect. So and in some instances, when it feels like when it thinks it doesn't have enough information, it tries to invoke a different function, which is the describe schema or mm-hmm. list tables to kind of get more info. So recall that when I said that the definition of an AI agent is an autonomous system that's aware of its environment, it's able to make decisions and execute actions, right? So if you think of everything I've mentioned, right, like it kind of illustrated all of those, right? So it's able to perceive its environment, which is like generally just the context it's operating in. It's able to make decisions such as like decide, right? And I say decide because I want to be very careful when I say that like these things think for themselves.
Yeah.
It decided to take this error and try to retry it in a different way. And it's able to execute actions, right? So it decided to, instead of, just running a brute force through different queries, it decided that it wanted to describe the tables and get more info.
Mm-hmm.
Yeah. And so and again, I want to like use this opportunity. And so like what that Langchain assistant class provides is basically, again, a unified layer like of how we think that these AI agents are shaping up, like the capabilities that we think are ready, on top of all the different LLMs and kind of like the ease of integrating it into your Ruby Rails applications. Yeah.
Awesome. That's so smart. I wonder how. I imagine that the SQL gem doesn't work with non-relational databases. I might be wrong. Do you have thoughts?
That library specific, it doesn't.
Yeah. Okay. So I wonder your thoughts on if there would be a use case, or if what would happen if you tried to implement something for Langchain.rb to query into a non-relational database.
Yeah, I mean, I'm still always constantly amazed with how knowledgeable these LLMs are.
Mm-hmm.
Like the other day, I was kind of playing around with Neo4j, which is a graph database, and it has its own query language, and like I have no idea what that is, or like I don't have time to learn it, but I can ask it and say, can you generate a query for me that's going to roughly organize the data in this way, and it generates valid Neo4j query, right? So it and it definitely knows about NoSQL databases as well, and it knows
Nice.
the Mongo sequence and the Mongo query syntax and the Elasticsearch syntax as well. So like there's no reason why we couldn't kind of enhance it and create a LangChain tool SQL database and then LangChain tool NoSQL database, right? And kind of start going into all these like different areas.
Neat. Thank you. Yeah. That was my question as a follow-up. I skipped this other question from the audience. Is there a benchmark compared to other languages like Python, Langchain being first built in Python?
In terms of like speed of execution within the framework, I'm unaware of any benchmarks. I will I will also I will mention this as well, though, that I just love this slide.
Yeah, it's great.
That something that I've seen in my career is that people that do data science, machine learning, AI, they tend to use Python. They're data scientists, and I've seen a lot that sometimes they lack in like their good software engineering fundamentals, like good software engineering principles, which is I don't know about you, but I've seen a lot of Python classes that the methods are like 500 lines long, none of it is tested, and it's really hard to follow. And I actually think this comes from like the Jupyter notebooks, because you just inline everything, and then once it's working, you just copy paste it, right? And again, the on the other side of that API boundary, the software engineers and also like in Ruby, I find that we have a really good concept of like object-oriented programming and very healthy testing culture. And again, I think there's an opportunity to bring this into the data science, the AI, the machine learning. So
yeah, I agree. I think that is an aspect I've noticed as well, not just with Python, but other languages. I feel like there is such a strong community in Ruby and Ruby on Rails, where we all sort of have agreed as a group to certain protocols and standards. And that is part of what makes it so enjoyable and easy to use. And it's very, very different. I've programmed in other languages, Java, JavaScript, Python, and the communities are more like disparate, just individuals in the world. They're all doing their own thing in their own way. Whereas Ruby feels a lot more cohesive as a community.
yeah. Do we have any other questions?
Let's see. Do we have a Ruby Jupyter tool?
I know you can run the Jupyter notebooks in the Ruby environment. I've tried it a couple times. I haven't perfected it. I mean, like we don't have like the first class support. Like Ruby doesn't have first class support for Jupyter notebooks, but well, we should. Like there's no reason why we shouldn't. And I mean, like, everyone has probably seen the work of Andrew Kane. He's like this sole open source developer who just built a million libraries, and I don't know how he maintains any of it.
Right. Where does he get the time? He's everywhere and nowhere all at the same time.
Brilliant and really nice guy. I've sat down for coffee with him before, and so I think we need to have like a broader community buy-in, because these tools exist and are developed in a snapshot in time, and unless large companies, the big, we can all name the really big Ruby shops, they have to get behind these tools. So otherwise it's not going to stick.
Yep, I agree. And that is the big driving force behind the Ruby community, really, is adoption. That's one of the big reasons that we're having this event today, is getting people seeing these tools and seeing open source and what they can do and being part of it. We have people mentioning a repo, SciRuby, for, imagining that's a documentation related aspect. I don't see any other questions at the moment. So we have an hour break scheduled to start in about a half hour, but that was such a really good in-depth presentation and demo, and you were doing it solo. So I feel like maybe we take a break a little bit early, break for an hour.
Yeah, that's perfect.
And then come back.
Yeah. Should we all come back at, I'm looking at 106 EST. Should we come back at top of the hour at 2 p.m. EST? What is it in UTC? Is it +5?
I think
or +6?
I think it's +5. I should know this, right? Yeah, let's come back. Let's do 10 after the next hour.
Okay.
And I'll put that everywhere so everyone knows that we're taking a break. But thank you so much. Thank you so much for that first half. It was such a good in-depth discussion. I'm really excited to see what we get into in the second half.
Awesome. Yeah, and so in the second half we have some issues prepared that Daniel and I are going to pair up, and again, very open to further questions, ideas, etc. All right.
All right. We'll see you all in about an hour.
Yep. Thank you. Thank you.
Thank you, everyone.